Hey there guys, welcome to GeeklyEDU. Today's video is about maximum and minimum of a function. In this topic, we are going to use what we learned in the previous videos about the derivative. If you haven't watched them, you are still on time to do it. Maximum and minimum are called extrema points of a function, and we have local maximum and local minimum. These extrema points are the coordinates where the function changes its direction, and the global maximum and the global minimum are the extrema points of a given interval. We can describe these previous terms defining a critical number of a function f. That is a number that we are going to call c in the domain of f, such that the derivative of the function is equal to 0 or does not exist. If the function has a local maximum or minimum in c, then c is a critical number and the coordinates c, the function evaluated in c, is a critical point. Now we know what is a critical point, a maximum, and a minimum. Now, how do we get those values? Assuming f is a continuous function on a closed interval ab, the squared brackets denote that the interval is closed. The first step is to find the values of the function in the critical points in the open interval ab. This is with the first derivative of the function and evaluating this value in the function. Then we have to find the values of the function in a and b, that are the limits of the given interval. And the final step is to compare these values so we can know the local and global extrema points. Let's practice these concepts. Find all the maxima and minima values of the function in a given interval. First, we have to derivate the function by using the rules of the derivative, and set the result equal to 0. We have to factorize and calculate the roots of this equation. In this case, we got 3 roots, 0, -1, and 1. Evaluating these values of x in the original function and the limits of the interval, we have 5 different coordinates. We can see which of the values of f of x is bigger and smaller. In this case, f of 3 is equal to 66, and that is a maxima point. And f of 1 and -1 is equal to 2. Then we have 2 minimum points. If we graph this function and the extrema points, we confirm that the minima is in f of x equal to 2, and that is a global and local minimum, and the local maximum is in 0, 3. The global maximum is in 3, 66. If we only want to know the local extrema, we can use the second derivative test, that works when the function has a first and second derivative on an open interval. The first step is to calculate the second derivative, and the second is to evaluate the values we obtained with the first derivative in the second derivative. Now, here is the rule of the second derivative test. If the value obtained is bigger than 0, then we have a minimum local value, and otherwise we have a maximum local value. Let's apply these rules to find the local maxima and minima values of the same function of the previous exercise. We already have the first derivative and the roots of the equation when we set equal to 0. Thus, x is equal to 0, -1, and 1. Now we have to calculate the second derivative. That is, the derivative of the derivative we got in the first example. And when we evaluate for the values of the roots, f of 0 is a negative value. That means we have a local maximum value in x equal to 0, and evaluating -1 and 1, we have a positive value, denoting it is a local minimum. We obtain the same result that in the first example by using the second derivative. This is everything for today, but before you go, write in the comments below in your own words what is the difference between the local and global extrema points.
Now that you watched this video, you're one step closer to achieving your academic goals. Well done! There's always more to learn, so check out our other videos and don't forget to subscribe.